Computer-controlled vehicles are equipped with a small motor used to help control idle speed, commonly called the ISC motor or idle speed control motor. Jim, when is the idle speed control motor actually used?
Well, like its name implies, Scott, it does control the idle speed. You have to do that sometimes, like whenever your air conditioner clutch cycles on when you're idling. Or perhaps you're idling for a long time at a traffic light and the engine starts to overheat or heat up. So the RPM would have to be raised to get coolant circulating.
Sure.
Sometimes power steering pressure reaches maximum effort one way or the other. This all gives extra demand on the motor, and this little thing right here will cause the idle speed to come up to compensate for these additional loads.
Okay, but actually they can be tested on or off the vehicle, and it's really not difficult at all.
Absolutely. When you get a trouble code for an idle speed control motor, generally it means that it's not working at all. And what you need to do is find out whether the motor itself is not working or whether something called the nose switch way out here in the front is not making contact.
Okay.
So this is a very simple two-part test. I like to use a battery to operate the motor itself. In fact, a 9-volt battery is one of the handiest things I've ever found, because if this motor will respond to a 9-volt battery, we know it will work flawlessly with a 12-volt battery that's on the car.
Certainly.
To test, you need to find the red and the black wires, which traditionally mean positive and negative in electronics, and connect those to your battery terminals. So as I connect the black lead to the negative battery terminal and the red one to the positive, it should extend the nose. And as you can see, it did that.
It sure does.
And to retract it, we simply reverse the connections on the battery, and it should move in the opposite direction.
And it did, without any binding.
Exactly. And without any binding, we know that this thing is clear. There's no nicks in the gears, and the motor, of course, is not damaged because it can actually work the mechanism.
Okay.
So, the nose switch, then, is the only other thing we need to be concerned with. And for that, I generally like to use an ohm meter. Now, the ohm meter can be attached across the other two leads. In this case, they are orange and purple. And I'll turn the ohm meter on, just most anywhere, down in the low range someplace. And that should, of course, supply us with some sort of a reading, showing continuity through the nose switch. Now, if you'll press that, the switch will open, and the reading will change to an open circuit.
Yep.
And every time you cycle that back and forth, it should change the meter reading.
And it does.
Now, General Motors idle speed control units work exactly the same way. They just have a different shape. Now, here you'll find that we do, in fact, have a nose switch, and we have terminals rather than wires.
Okay.
Now, these terminals are arranged this way. The two closest to the motor are for the motor. The two furthest away are for the nose switch. So normally I like to use my meter leads as all the test equipment. So since we're still connected to the meter, why don't we just go ahead and check the nose switch. So if you'd like to hold on to that, and I'll hold the meter, and we'll put these two leads into the terminals farthest away from the motor. Remember, those are the nose switch terminals. And we'll turn the meter on.
Okay. And we have actually an open circuit showing there. And now I'll push it in. You hear the switch click. And we show continuity one way, open circuit the other way.
Right. So now we know that nose switch works.
Certainly.
All we'll have to do now is test the motor. I'm going to take the leads right off of the ohm meter and use them for jumper wires.
Okay.
That way, we can use the same probes in the other two connectors, the two that are for the motor. And that gives us a real nice way to connect up. And then we'll use the other ends, of course, to connect up to the battery. And as I connect one lead to this terminal and the other to that, you can see how the motor moves out. And it should retract when I reverse the leads.
And it does, without binding. So
this is a simple test that they can do. You can do at home in order to test your idle speed control motors.
And one last point, you can do that on the vehicle or with the component off from the vehicle.
Let's look at how easy it is to test an idle speed control motor. Connect the idle speed control electrical leads to a test battery. Observe the nose switch movement and the idle speed control motor sound. Reverse the electrical connections and observe the idle speed control nose movement. Connect the ohm meter leads to the idle speed control motor and set the meter to the appropriate scale. Observe the meter reading. Depress the nose switch. and observe the meter reading. To replace your idle speed control motor, the tools you will need include a set of screwdrivers, a pair of pliers, a 1/4-inch drive socket set, some masking tape and a marker, a tape measure, the proper service manual, and the correct idle speed control motor for your vehicle. Before beginning any repairs under the hood, always begin with a cool engine. The first step whenever working on the electrical system is to turn off all electrical accessories, including the ignition key. Idle speed control motors are attached to the carburetor. Begin by removing the air cleaner housing cover. Mark all hoses and wiring connections going to the air cleaner housing and remove the housing from the carburetor. Locate the idle speed control motor and disconnect the 4-terminal connector. A small screwdriver may be useful to help release the locking clip on the connector. Using a pair of pliers, remove the throttle return spring from the idle speed control bracket. Remove any mounting screws from the idle speed control bracket and remove the idle speed control motor and bracket from the carburetor. Compare the old idle speed control motor and bracket to the new one to be sure it is the correct replacement. If the old bracket differs from the new one, remove any mounting screws from both brackets and install the old bracket onto the new idle speed control motor. Next, you need to adjust the plunger on the new motor. Distance A, as shown in this illustration, needs to be determined. Measure the distance between the end of the plunger and motor housing on the old idle speed control motor. This is distance A. Now measure distance A found on the new idle speed control motor. If the distance measured from the new motor is different than that on the old motor, adjust the plunger on the new motor to match distance A found on the old motor. Then, using the mounting screws removed earlier, reinstall the new idle speed control motor onto the carburetor. Carefully reconnect the electrical connection on the motor, making sure it is fully seated. Once the new idle speed control motor has been installed, a base and extended RPM speed check must be performed and adjustments must be made. Please refer to an automotive service manual for the correct service procedure and idle specifications on your particular vehicle. Now reinstall the throttle return spring to the same position as removed earlier. Reinstall the air cleaner housing and reconnect any hoses earlier disconnected. That's all it takes to replace an idle speed control motor. Replacing the idle speed control motor is an easy job. Let's look at the steps involved. Turn off the electrical accessories, including the ignition key. Remove the air cleaner assembly. Locate the idle speed control motor. Disconnect the electrical lead from the motor. Remove the throttle return springs from the idle speed control bracket. Next, remove the mounting screws and assembly from the carburetor. Adjust the plunger length of the new idle speed control motor to match the old motor. Install the new idle speed control motor and bracket onto the carburetor. Next, reconnect the electrical lead. Refer to a service manual and perform an RPM speed check on the new motor. Reinstall any throttle return springs. Lastly, reinstall the air cleaner assembly to complete the replacement.